by all means necessary, we're going to get it.
Rockstar lifestyle. Ask her
Hey, I done been lied to. I've been neglected.
Homies, what's good? It's Mr. B again with Lesson 2, Unit 7, Intersections on Graphs. The only intersection that we have talked about explicitly so far, y-intercept, x-intercept. Think about what that means. The y-intercept and the x-intercept. What is that? Remind yourself of what that is. Okay? Intersections on graphs. All right. A system of equations is a set of two or more equations. A system of equations is a set of two or more equations. So a system. Think about a factory. There are systems. Your body has systems in it. They work together. Same thing in mathematics, systems of equations. We call them simultaneous equations sometimes. Some people call them simultaneous. What does the word simultaneous mean? Think about that. What does the word simultaneous mean? And a system has three types of solutions. We're going to talk about a system of equations, meaning two lines, or more. For our purposes in Algebra 1, it's just two lines working together. But a system has three types of solutions. The types of solutions are no solutions. What the heck's going on with that U? That is a U, by the way. No solutions. One solution. And then finally, infinitely many solutions. Infinitely many. Infinitely many. Oh, I'm so sorry with my handwriting. Infinitely many solutions. Solution. So those are the three types, and we're going to talk about them right now. All right. This is an example of a graph of a system that has one solution. Right now, real quick, think about why this might have one solution. Why might it? So the reason why we say that this system has one solution is because it intersects in one location here. That is the intersection point. That means that this point falls on both of these lines, which means that this point satisfies both equations. This line has an equation, this line has an equation. This point satisfies both. Really think about what that means. Rewind the video if you need to. Think about what that means. This point satisfies both equations. It's on both lines. It satisfies both equations. This system has one solution. This system has no solution. Why do you think it might not have a solution? I can tell you why. These lines will never ever intersect. They're parallel. These are parallel lines. They have the same slope. They will never intersect. Hence, no solution. Finally, notice how there are two lines here, but this is what infinitely many solutions would look like. Here's a line, okay? Infinitely many would mean that another line would be the exact same as this line. So another line, if I were to put another line that's the exact same, it would fall right on top of this line. So, see the blue and then see the red? It's the same line, just in a different form. And this is what I mean by that. This is how it looks. Can you notice anything about the relationship between this line and this line? I'm not even going to say anything else. else, because I'm going to see if you can figure that out. Talk with each other to see what's the relationship between this line and this line. I'll give you a hint. They are the same line, but why are they the same line? That's what an infinitely many solutions system would look like. Let's do this problem. Marcus and Sari both deposit money into an account. Marcus deposits blah, 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 blah. Okay, let's get down to business. This system of equations has 0, 1, or infinitely many solutions because, why don't you figure that out? So, right now, looking at this system has 0 solutions. It's kind of a trick question. This system has 0 solutions. Why? Because the lines never intersect. 0 solutions. The lines never intersect. Now, let's assume that these lines are infinite. They wouldn't be infinite in this case because what are we dealing with? We're dealing with money. And although we could go negative, that would mean we owe money. In this case, it's just showing the first quadrant. But for all intents and purposes of the lesson, let's say if these lines were to continue. Let's make them infinite. Let's get the context of the situation out of the picture. If we continue the lines, the system does have a solution. But in this case, it wouldn't really make sense because, well, we're in quadrant 1, and we're only focused on making money. You know, we're not really, we're saving up money. If we were to continue these lines, yeah, I mean, they would intersect eventually. Okay, but again, we're focused, Marcus and Sari are depositing into account, we're hopefully focused on saving money. Okay, we are not going this way because they're not starting with a negative number of dollars. They're starting with 150 and 200. They're starting here. They're not starting over here. So we don't have to worry about this intersection. This solution, presented how it is, has 0 solutions. Okay, and then which equations belong to each other? Well, it's kind of simple. Why don't you try it? What equations belong to each other? All right, so Marcus's equation, well, what's it say? Marcus deposits $200. And Sari deposits $150. So their starting points, or y-intercepts, are different. Marcus's is this one. Notice how the y-intercept is 200. Sari's equation is this one. Starts with 150. And you can kind of use context clues to see how it looks. Sarah sells small and large homemade candles. This weekend she sold 3 small candles and 2 large candles and collected $18. Last weekend she sold 6 small candles and 4 large candles and collected $36. All right, so we do have 2 lines there. It appears like we don't, but we do. Take a look. This equation is pointing to the same line. The 2 equations that appear different are pointing to the same line. That's a big indicator right away. This system of equations has infinitely many solutions because what? What do we notice about these 2? Is there anyone that can tell me? Well, you can't tell me because it's a video, but think about it. So we know that this system, these 2 equations, have infinitely many solutions. And the reason why is because this equation is this equation. just multiply by 2. Notice how 3 times 2 is 6. 2 times 2 is 4. 18 times 2 is 36. So they are the same line. There are no different variables. Nothing is different except this line is this line just multiplied by 2. Okay? So how can we tell that both lines are the same? For the reason that I just said. This line is this line just multiplied by 2. So perhaps an indicator that could give whether or not a system has infinitely many solutions is you can look at it and you go, okay, what factors do I notice are in common? This and this, there's definitely something going on here. This equation is just multiplied by 2. All right, so that's it for lesson 2. Again, I went really fast. If you wanted some things to take away, think to yourself, what is the intersection point? That is the solution to the function. Another takeaway is infinitely many, no solutions, one solution. What do they look like? And then the context will come over time. So perhaps what I would do is, whenever you're completing these problems, word problems, is